I just want to get a quick show of hands. Who here has written or knows how to write JavaScript? Okay, so most of you. All right, that's good because this workshop is mainly targeted towards you guys. And I just want to kind of explain why I use TypeScript and why I think JavaScript developers can benefit greatly from using TypeScript. So I'm going to go ahead and show some statistics. So this first statistic is a survey that was done in 2020 for JavaScript developers, and it was asking them what features they wanted the most. And I don't know if you can read that, but at the top, the overwhelming majority of people just wanted static types. And TypeScript pretty much solves this issue or gives them static types with all the features of JavaScript. So there's definitely a want for TypeScript or statically typed languages in the JS ecosystem. In fact, the founder of Node.js, Ronald Dahl, he basically said that TypeScript is the future. And you can take that as it is. That's one person's opinion, but he has had a sizable impact on the entire community. On Stack Overflow, on their developer survey, TypeScript is the third most loved language, right under Clojure and Rust. And then in terms of what people want, people actually are wanting nowadays a little bit over JavaScript. They want more TypeScript developers. So whenever I bring up TypeScript, there's always people who have very strong opinions against TypeScript. They think it's annoying and they think it's more typing, and because I have to do more of that, then it's a worse language. So I just want to kind of address some of those concerns some people have. So the most common concern I see online is that it's more typing than JavaScript, so it's going to increase your development time. And this is a very common misconception. Your development time is not equal to your amount of typing up front. Your development time is more, I guess, impacted by how much debugging you do while you're programming. And in TypeScript, I've honestly found myself debugging a lot less. And because of that, I've been able to make iterations and make changes in my code a lot faster. And as a result, I've been more productive as a developer. So the investment up front in TypeScript pays very large dividends in the outcome of your productivity when developing in the JS ecosystem. Also, a lot of people who say it's a lot of typing, they're also the same kind of people who do stuff like prop types. And so at the top, that's actually JavaScript for declaring prop types for React. And then at the bottom is declaring types, doing the same exact thing essentially, but in TypeScript. In this case, it's actually less. And also documentation in JavaScript, they have something called JSDoc for declaring types. It's sizably more typing than just using an interface like you would in TypeScript. So how does TypeScript help? And the answer is it's statically typed. That's the biggest thing that helps all the developers out. And basically, when I say statically typed, the types stay the same and they're predictable. They don't change during runtime. And it helps you write safer and more reliable code. And I'll go into the details of this. Sorry. So one of the main things it does that I like is it gives you a lot better lookups. So this includes autocomplete. So right now what we're looking at is a JavaScript lookup. It's trying to find out where this client class is being used in the code base. And this client class is actually being used in 83 different places, but the issue is it's only picking up 3 of them. And that's because in a weakly typed language or a loosely typed language, it can't properly look up everything in there. Does anyone know why it's bad that it can't look stuff up? Like, why is that a negative? Does anyone want to know? Why? Yeah, exactly. If you don't know where your code is being used throughout the code base, if you need to refactor something, then you can't really refactor it because you're only going to change it in the place that it's like declared. you need to be able to change your code and have it change everywhere. So it's very difficult for refactoring. So yeah, it's very hard to refactor this type of code. And JavaScript in general is very hard to refactor because you don't get very good usages. And so this is the same usage lookup I did on the same class. And this is it in the TypeScript types. You can see I'm getting 89 instead of 3, which is showing me the actual usages of the class. So I can feel confident that if I refactor anything in this client class, that all those changes are going to be affected throughout the code base. I don't have to worry about me going through every single file or doing a very sloppy find and replace command. And obviously, JS has a ton of issues just by itself, besides types, like implicit type coercion, confusing this types. I don't know if anyone's experienced that, but that this type in JavaScript is very, it's very confusing because it can mean different things depending on where you use it. And then sometimes people, one of the ones I see the worst is improper destructuring. People do a typo when they destructure something and it'll cause their program to crash. And then unsafe nullish access, that's another big one. You'll get oftentimes type error, undefined, or cannot run function on undefined. And that just happens most of the time because you either misspelled something or you didn't load your object in properly. And so all of these can have some pretty cascading effects. Oh, let me turn this down a bit. So yeah, that's what happens when you use JavaScript. So that's great and all, but yeah, I'm not going to play anything else. That's fine.
Fine. Just making sure.
All right. So all of these benefits are great, but can these actually be quantified? Is there any evidence that this actually helps us be better developers? There actually is. So there was a study done with TypeScript, comparing it to JavaScript, and they said just at a baseline, just by converting your code to TypeScript, they said on average, you're probably going to remove about 15% of your bugs from your code base. And the cool thing about this is your mileage may vary with this. So Airbnb, I don't know if you know who they are. Well, they're the the company, but they also are a big developer and they're known for their very strict coding guidelines. And even a company like that, they couldn't even, they had a higher amount of bugs they were able to eliminate, which converting their JavaScript code to TypeScript. So they had 38% of their bugs just removed entirely because they moved over to TypeScript. And that makes sense because in these large code bases, JavaScript is not scalable. So you're going to have more and more bugs as your code gets bigger. Okay, so how does TypeScript work? So TypeScript works by you starting off with TypeScript source code, as you can see at the top. And then it goes into something called the type checker. And what the type checker does is it makes sure that all your types are being used properly. This is the part that powers TypeScript. That's the reason it's called TypeScript. And if something is mismatched or your type is off, it won't compile. And you're going to have to fix your code in order for it to compile. So once it passes the type checker, it goes to the TypeScript transpiler. So a transpiler is a word. It just means it converts one language to another. That's what it means to transpile. So what it's doing here, it's transpiling TypeScript into JavaScript code. And then finally, at the end, you end up with pure JavaScript. You can see here, they look pretty similar. In this instance, they look similar. That's because TypeScript is a superset of JavaScript. And what that means is all JavaScript code is valid TypeScript code, but not all TypeScript code is valid JavaScript code. So you see, we end up with that JavaScript at the end, and then we can use that JavaScript code anywhere JavaScript is used, which is nice because it's portable. So I just want to end the PowerPoint part with some frequently asked questions I get. And one of them I get a lot is, does that mean I can use TypeScript anywhere I use JavaScript? And the answer is yes, you can use TypeScript anywhere you use JavaScript. it's a superset of JavaScript, and it's eventually transpiled to JavaScript, which means anywhere you use JavaScript, you can use TypeScript. And then another question I get is, does TypeScript affect the performance of my apps? And similar to the last answer, no, it's identical because it's still, at the end of the day, transpiled JavaScript. So it's going to be the same performance you get from JavaScript. And then can I have TypeScript source files along with JavaScript source files? And yes, you can. You can actually mix and match different types of files together. And the compiler supports checking JavaScript files if you want that. So yeah, there's built-in options to work with that. And then does a library need to be written in TypeScript for it to be used in a TypeScript project? No, you can actually use pure JavaScript libraries in a TypeScript project. But most of the time, you're probably not going to do that because most of the popular libraries come with type libraries if they're not written in TypeScript. And those offer a way better experience than just using a vanilla JavaScript library. And the last question is if given a choice, should I use TypeScript over JavaScript? And the answer is obviously. The reason is because as more time goes on, there's more and more people adopting TypeScript instead of using JavaScript for writing libraries. And if you're also writing TypeScript, you can take advantage of all those features in those libraries. And you can have a lot safer code. And it's just a win-win. And even if your code isn't that big, you can still see the benefits of TypeScript. Because if you use a complex library, an example I had earlier was discord.js. I was working with someone who only had one file of code of discord.js, and they were still messing it up because the types from that library were so complex. And if they just used TypeScript, it would have eliminated all their issues. So if you're starting a new project in the Node ecosystem or the JS ecosystem, I highly recommend you start it in TypeScript. And if you don't have the choice, or you've already written code in JavaScript, I'd recommend maybe slowly integrating TypeScript into your code base, or writing a type library for your already existing library. All right, so that's the presentation. I'm going to go ahead and go to the demo. Great. Let me check the chat here. Okay. Okay, so the first thing I'm going to do is I'm going to go ahead and open up my terminal. You can use whatever terminal app you want. You can use command prompt if you're in Windows, or the Ubuntu shell in Windows. So I'll go ahead and open my terminal. And I'm just going to create a new NPM project. So I'm going to make a directory called TypeScript demo. And then I'm going to move into that directory. Okay, and then I'm going to do npm init -y to skip the questions. And then I am going to open up VS Code. I'm going to open, and I'm going to go to that folder that I made right now. All right. Okay. Can everyone read that? Is it too small, or does it need to be bigger? Is it good? All right, thanks. All right, so what I'm going to do is the first step in using TypeScript in any project is you need to install the TypeScript compiler. It's pretty easy if you have Node installed. All you need to do is run npm i and then TypeScript. Now, I usually install it globally, so I'm going to do the -g flag. So it's everyone on my computer. So I'll go ahead and install that. And now I can check if it's installed by doing tsc -- version. And I'm running version 4.4.3. Okay. So now I'm actually going to write some TypeScript. So I'm going to create a file called index.ts. And then I'm going to just go over some basic concepts in TypeScript. So the first concept I want to go over is types. And types are the fundamental thing that makes TypeScript what it is. So the most basic way to define types is via interfaces. And interfaces define how object types should be laid out. So let's say I want to create an object type for a person. I would declare an interface by typing interface, the name of the interface, and then I put in the body the different fields that this person would have. So they would have a first name, should be a string, a last name, sorry. It should also be a string. And then an age, which would be a number. And so what I can do now is I can use this type for any object that I declare. So let's say I declare a new a new object called me, just for me. And I can set a type on this constant. So I'll set the type to person. Then I set it equal to whatever. And here I'm going to put the properties in that I want. So I'm going to put my name, my last name. And then let's just leave it. So if you notice here, it's not very happy with me because it's saying that age is missing in this type. And it's saying age is declared here, which is referring to right here. And it's basically saying that age is required and you can't just leave it out. You need to have all those properties that are defined up there. So let me go ahead and fix that. And I'll say I'm 21. Okay, it's still mad at me. And I'm pretty sure you can guess why. I put a string here instead of a number. And the error here is pretty obvious. Type string is not assignable to number. So let me go fix that now. And then it's happy. All right, so let's see what happens when I compile this and what we get. So I'm going to go to my terminal. I'm going to run tsc index.ts. So I'll hit enter and it's going to compile it. All right, and now it's done. You notice we have a new file here called index.js. This is the transpiled file from index.ts. So if we look in here, you'll notice that it just has the object here. It doesn't actually have the interface, and that's because types are erased during runtime. There's no types in types or JavaScript, so it just gets erased. So you just end up with an object. So this is just JavaScript compatible code. All right. Another thing I wanted to show was more complex objects. So more specifically, variant objects. So variant objects are objects that share some qualities with each other, but they have slight differences. That's why they're called variants. So to demonstrate this, I'm going to create two shape interfaces. One of them is going to be square, and it's going to have a property called side length, which is a number. Then the other interface I'm going to declare is called a circle. And this one doesn't have a side length, it just has a radius. Okay. So I have these two object types here. And now I actually want to calculate, I want to have a function that calculates the area given any of what these two shapes. So I'll do function, calculate area, shape. And then, oh, sorry, I need to. Okay. So you notice here that shape is, it's going to yell at me because it doesn't know what type I have for shape. It doesn't know what this function exactly is receiving. So what I'll do is I'll annotate this type. So to annotate a type, you just type a colon and then you type the type after that. So in this case, I want it to be a circle or a square. I want to calculate the area of any shape that's given to me. So this might be confusing here because how do you represent a function that takes in, or a function parameter that takes two different types? The way we do that is we use something called an a union type. A union type is just two types that are either or. So you can only have one of the types that you specify in the union. So as an example, for a union type here, I'll do circle or square. And then I would actually do my calculation here. Now I'm going to run into an issue here because how do I tell which one's passed into me? I can't do an instance of check because it's not a class. It's just an object. So how would I tell if I'm getting a circle or a square? To solve this, we have something in TypeScript called discriminated unions. And so a discriminated union is called that because it has a field on each of the types that discriminate what exact type it is. So in this case, I'll add a discriminator called kind, and I'll set it to square. Square. And this is our discriminator. And then on circle, I'm going to set the kind to circle. Because of this, TypeScript can now discriminate which shape we're going to have. So when I do my calculation here, I can say, okay, check if it's a circle. I'm going to say if shape.kind is equal to, and look at this, it also gives you the autocomplete for the different variants you have. So I'm going to choose circle, obviously, because I'm checking if it's a circle. Then return shape.radius. Hold on, it's 3.14 times shape.radius. I'm just going to do this really sloppily. Shape.radius. So that's the area of the circle. Okay, now what about the rectangle? Well, I can do another statement here that checks if it's a rectangle. If I do if shape.kind is equal to rectangle. And this will work just fine, actually. Oh, okay. So, sorry. So you would expect this to work, but it actually doesn't. And the reason why is because TypeScript's already 2 steps ahead of me. It already knows that this is never going to be, actually, wait, hold on. Oh, sorry, it's not a rectangle, it's a square. Okay, wrong error. Okay, so I could check if it's a square down here, just like I did up there. However, I don't actually need to check if it's a square because we already checked if it's a circle here. And the only other thing it could be is a square. So I can just omit the if statement. I can just do return shape dot side length times shape dot side length for the area of a square. And that will give me the area. And it's all type safe. So even if I try to, let's say, return shape dot radius, it's not going to let me because I didn't show if it was a circle or a square or not. So it's just going to say that doesn't exist on square because we already proved it's the circle. So that's how you have different variant types in TypeScript and you can protect against them. The last thing I want to show is generics. So generics, if you use any other strongly typed language, it works pretty much the same in TypeScript. So I'll declare a class called box, and this class will have a value that I store into it. So I'll have a value, and I don't really know what the value is going to be. So I'm just going to set the type to any, and any means I don't know what it is. So I'll set it to any, and then I want to have a constructor to set the value initially. So constructor value any this dot value equals value. So we just set the value in the constructor. And now I just have a basic class here. Fun fact, in TypeScript, you can actually omit this whole entire body if you just do, or you can actually clean this up a lot. If you just remove value, you do private value, and then you can remove the body entirely. You just have this. All right, so what I'll do is I'll create a box type, and I'll say const my box equals new box. And then I'm going to put some arbitrary value into it. I'll put like 1, 2, 3. Okay, and then I'll have another box. Three. And so I'm going to get a value from the box. And let's say I want to say const my number equals my box dot value. Sorry, this needs to be public. You notice if I hover over this, it's saying that my number is any, which is not true. It's actually a number because I declared a number up here. The reason is that I need to represent a type that can actually handle any kind of different types here. This is always going to be any, which isn't very type safe. I need to find a way to actually allow it to carry different types than just any. So what we can do here is we can change this to a generic class. So to do that, it's pretty easy. You just create a generic parameter right here, and we usually call it T for type. And then what we can do is we can carry this generic parameter down here to the value and set that as a value type. So now when I do my number, it actually shows up as a number now because it automatically inferred based off of what I passed in that it's going to be a number. And now the type is a number. Same thing for the string. So if I do const my string equals my box dot value, you can see here that oh, sorry, not my box, another box. You can see it successfully picked up that it's a string. So that's the basic part, but what I'm going to do now is I'm going to open up an already existing JavaScript project and show you how you would go from JavaScript to TypeScript. So let me open that up. Okay, and so we're just going to go into the index.js, and in this file, I'm actually running into a bug. So I have two employee objects here, and I'm going into HR, and then I'm hiring these employees. The issue is that when I run this program and I filter the employees by software, sorry, let me just put that comment there. I'm only getting one employee back, even though I hired two employees here. So I'm trying to figure out what the bug is here. So I'll do npm start so you can see. So it's only showing one employee. And I'm not sure where the bug is. This is all written in JavaScript, so I can kind of check in my source code here. And I can see, oh, well, I missed the ID property here. So, okay, let me put that back. Let me put the ID property here, and maybe that'll fix it. So I'll say ID is 1, 2, 3, 4, or actually, what's the type on them? It's a string. Okay. And then ID is 1. All right, so let me try running this again and see if that fixes it. Okay, it's still not working. I'm not really sure what the issue is here. I don't really feel like debugging it right now, but I can tell you right now, the issue is I actually misspelled something here, and we can see that immediately just by converting this to TypeScript. So how do I convert this file to TypeScript? So the first thing you do is you go to rename, and then you rename the file to index.ts. Okay. And we are immediately greeted with an error. And it's saying, oh, this age is supposed to be a number. So that's as soon as you rename it, it gets parsed as a TypeScript file. And notice that this is completely valid TypeScript. You don't have to do anything beyond this. And it's actually, in this case, identical to JavaScript at this point. The only difference is it's enforcing that you do proper types. And now let me go ahead and convert my actual HR class to TypeScript. So I'll do the same thing. So I'll rename it from hr.js to hr.ts. And then let's first get rid of this type def because it's pretty big and just in the middle of the class. And let's instead declare an interface. So I'll do interface employee. And then I'm just going to translate everything over. So first name, string, last name, string, ID, string, department, string, and then age, string. Okay, so we can go ahead and get rid of this now. All right, so now it's complaining because it's saying, it says it has an any type. It doesn't like, TypeScript doesn't like the any type. So we need to type this parameter. So what we'll do is we'll set the type annotation on this. So we'll do that. We're accepting an array of employees to hire. So we'll do employee and set that array type. Okay, well, now I can see actually where I went wrong. So in my for loop, I was accidentally accessing ID on the employees array, not the employees element. And that was causing some of my hires not to work properly. So what I need to do here, it's saying, oh, ID does not exist on employee array, which is true. I need to just fix that. Okay, now it's happy. And so let me go back to my index.ts and see if it, oh, age is supposed to be number, did that 2 times. So let me go back to here and run my program again and see if that fixed it. And as you can see, it does both of the employees now, which means the error has now been fixed. And I was able to easily identify where I went wrong just by converting files simply over to TypeScript. Now, I want to go a little bit farther with this, and I want to have departments, but I only want a selection of departments you can select from, a limited amount. So I don't just want it to be any arbitrary string. There's only certain departments we have. So let me go ahead and make something called a type alias for our departments. So I'll type, and then I'll do departments. And I'll set it equal to a union of different type strings for our departments. So in this case, we have a software department. We also have a hardware department. And we also have a graphics department. And what I'll do is I'm going to replace this string because I don't want just any regular string, and I'm going to replace it with a departments type. So let's see how that affects our consumer code. So I'm going to make an improvement here. Instead of just declaring a straight up object here, I'm going to annotate the type on this, because if you look at the type here, it's pretty ugly. This is a really big, large object. So what I'm going to do is I'm going to, first let me export this. Export interface. I'm going to use the employee type. So I'm going to annotate these as employees. Okay. And what I'm going to do is, let's say I incorrectly or I put the wrong departments. Let's say we have a design department, which we don't have. And I put design. It's going to yell at me because that's not a valid choice. You have to use any of the options that you declared in this department type. You can't use anything else. It needs to be one of those. So that can protect it from any unwanted strings. Now this is great, but each department or each department you work in, you have a different rank, right? You're a manager, or you're an engineer, or you're manager, engineer, or you're, I guess, director. So let's say I want something where it's like the department can either be software manager, software manager, software director, and then software engineer. And I want that for every single department. I don't want it just for software. I don't want it for hardware, software, and graphics. So I could go back into here and type all of those out manually, but you really don't actually have to do that. You can use something called a string template literal to actually calculate all those combinations for you. So string template literal. And then what I'm going to do is I'm going to do export type, positions. I'll say engineer, director, and manager. And what I'll do is I'll instead set the type here, instead of just departments, I'll do it in an actual literal string. And then what I'll put in this literal string is departments, space, positions. Now let's go back to our consuming code and see what happens. So it doesn't like what we put for department here. And if you look here, it generated all those different combinations in the little tooltip. It's saying my software part is not assignable to any of those strings that's in there. So I need to choose a string to put here that's compatible. So I need to put software, I'll do manager. Then for here, I'll do software engineer. And you can change this first part or second part to any of those valid types and it'll just work. But it just enforces that each of those types are being used properly. I think graphics, yeah. But let's say that I don't need all my employees. I don't need their age. It's not required, and I don't really want to provide it every single time. So what happens if I delete it? Well, it's going to yell at me because age is in that interface. So what I can do instead is I can do something called marking it as optional. So to mark a property as optional, you just put a question mark after the property name. And that says this property can exist, but it won't always exist. It might be undefined. So if I go back now and see my employee 2, I omitted the age, but it's okay with that because it's an optional thing. So it doesn't have to be there. So yeah, that was just a small demo of TypeScript. I'm just going to open it up to questions now if anyone has any questions about TypeScript. Let me check the chat. Okay, then I'll go ahead and end it here. And
Does Zoom have any questions?
no.
Okay, someone might be done typing something else. I'll give it a minute.
Okay. Oh yeah. Oops. So me personally, I learned JavaScript first, and it really helped me learn TypeScript because obviously TypeScript is a superset of JavaScript, so it's very easy to go into. In terms of learning, yeah, you could just go straight into learning TypeScript, and but I would still recommend learning JavaScript. The reason is because if you ever need to maintain legacy code or something like that, it's a good skill to have. So I would probably just learn TypeScript first, or sorry, learn JavaScript first, then transition into TypeScript. So I'm in the middle of learning JavaScript. Should I just learn TypeScript instead? So if you're in the middle of learning JavaScript, you're actually kind of also in the middle of learning TypeScript because again, TypeScript is a superset of JavaScript. So what I would do was I would just probably complete learning JavaScript. And then once you're done, I would jump into TypeScript and it would be a really easy transition because they're both very similar languages.